So your question was exercise 8.4 Roman number 5. So I have solved the entire question. I will just explain you from here so that it will save your time. So your question was this, that is cos A minus sin A plus 1 cos A plus sin A minus 1 equals to cosec plus cot A. So this is your LHS, this is your RHS. You are supposed to prove them as equal. Now how do we do? So the choice is yours. You can take RHS and you can prove it to LHS or vice versa. So this time what we are doing, we are taking LHS. Okay, you can do with RHS also, no problem. Choice is yours. Whichever you find it easy, you can go with that. Now since we are doing with LHS, you repeat the same thing again here. So once it is done, now here what do we do here? Now here we will do rationalizing. Now what is rationalizing? You see, now this is called numerator, this is called denominator, this is in fraction form. So always whenever we do rationalizing, we do with the denominator, that means with this part. Okay, so repeat the same thing here. We are writing the same thing here. Now you put into here. Now this is your denominator. Now denominator you repeat 2 times here. Now write the same thing here, but there will be a slight change, that is we will change the sign. So this one cos A plus sin you consider as A, and minus 1, this one you consider as B. This part is your A, this part is your B. So you just write the same thing here, but this is your A and this is your B. Now this is minus here, so it will change to plus. The same thing you repeat here, the same thing, even the sign, everything will remain the same. This is called rationalizing. Why do we write the same thing? Reason behind, you see, when you cancel, you can cancel both of them. Since both of them were same, when you cancel you will get as 1, and when you multiply you will get back to the same thing. So rationalizing, whatever you do, when you solve it back, you should get back the same thing. Okay, so that's the reason here. Now here you see, you might be confused that here we are using plus since it is minus, but here it is plus, but we are keeping it plus only. Why not minus? Now the thing is that, as I've already explained you, this one you consider as A and this one is B. This one is B, A and B. So both of them, the sign in between is this, and since we have placed bracket here, we don't change it. Okay, if you haven't placed the bracket here, so the sign will change. So just to consider as A and B, so that later on we can apply formula. That's the reason we are doing it like this. Okay, so this is called rationalizing part. Now the next part you see, now here you see, this is the numerator portion. Now the numerator portion, we will do a slight changes here just to bring under the formula called a square minus b square. Now how we are doing this, you see, this is cos here, 1 we put it here, it is plus 1, that's why it's plus 1, and minus sign it's here. Same we have done with this also. Okay, we have just changed its place. Okay, now we so that it falls under a formula called a minus b, a plus b, so which will give you this formula, a square minus b square. And here also we have done the same thing. We have placed this under bracket, minus 1, same thing, we are repeating the same thing. Here we didn't do any changes. Numerator remains the same, only denominator remains the same. Numerator we have done some changes. Now the next part you see, this is A, this is B, A minus B, A plus B. Formula is A square minus B square. Same with this also, this is A, this is B, A, B, A minus B, A plus B, A square minus B square. Now this is from the formula called this. Okay, now next portion, now the expansion is A plus B whole square. A plus B whole square, the formula is A square plus B square plus 2AB. Okay, so we are expanding as same thing, A square plus B square plus 2AB minus that is sine square. Okay, this is from the formula from this, minus and minus. Same with this also, you see, A plus B whole square, A square plus B square plus 2AB minus 1 square. 1 square is 1 only. Okay, this is just the expansion of the formula. Now the next part you see, here what you have done, we have done some arrangement here. Now how do we have done the arrangement? You see, cos square, it is here. Okay, 2 cos A into 1, when you multiply you will get back this 2 cos A. Okay, now here you see this one, plus 1 square. Okay, 1 square is 1, so it is here, plus 1 square, and minus sine square here. Reason behind, these two we have kept here, these two we have put it here. Reason behind, 1 minus sine square, we have a formula called cos square. Okay, just to bring this under formula, we are doing it the same. Okay, now this portion we have repeated here. Now for this again, cos square plus sine square, that gives you a formula called 1. Okay, under identities formula, cos square plus sine square or sine square plus cos square is the same thing. It gives you 1. This one, 2 cos a sine a remains the same, minus 1. Okay, now once it is done, 1 cancel. This is plus, this is minus, you can cancel. That's the reason we are cancelling here. Okay, now look at this portion. We are doing it here. Cos square, it is here. 2 cos a is here. Now plus 1 minus sine is cos square. Okay, so this comes under the formula. So this has changed to this. Then this two has cancelled and we have got this one. Okay, now the next portion you see. Now next, now there you see cos square plus cos square, 2 cos square a, again plus 2 cos a, same thing, again repeat the same thing here. Okay, done. Now next step, 2 cos a plus 2 cos a. Okay, what is common both the portion? That is cos a, 2 cos a. So we took common out of this is 2 cos a. Now this is already square, so what you will do, you will place cos a here. So when you multiply, you will get square, and 2 is already out. So when you multiply, you should get back the same thing. You multiply this 2, you will get back the same thing. Plus here, this is already out here, nothing is left, so we will place 1 here. So 2 cos a into 1 will give you the same thing. Okay, this is how we do the common. Now this denominator will be the same thing here. Now out here you see what is common, 2 cos a and 2 cos a, same, cancel them. Okay, now this is left here. So what do you do here? The same thing you repeat here. Now what do you do? For both the case, for both the value, we have got sine as common. Okay, so usually we get this after doing LCM. Now what is the reverse of LCM is this way. You split them. Sine cos, it's here, plus 1 sine. Okay, cos for both of them sine is common. Okay, usually we do this in LCM. So this time we are doing it in reverse way. Okay, so you see we have got this. When you solve it, you'll get back the same thing. Okay, we are doing in reverse form. Okay, now here you see cos a by sine a, that gives you the formula, inverse formula, cot a. Same with this, 1 by sine gives you cosec. Okay, so here you see we have got your RHS, but your RHS according to your question, it is cosec plus cot, whereas we got here cot plus cosec. Okay, both are correct because both their sign is same. So just to satisfy your question, that is RHS, you just change their place. You bring cos first and you bring cot second. Okay, so it is exactly now your RHS. That is, since we have got the answer, you write at the end LHS equals to RHS. So that's all. If you have got any doubt, you can mark that portion and you just ask me for more explanation.